universe. In India as well, astronomy has been a field of study for centuries now. India first ventured into space in the early 60s, when Dr. Vikram Sarabhai laid the blueprint of the Indian space program. It focused on the use of space technology for the benefit of the common man. With the deployment of PSLV, it was now possible for India to launch a payload of reasonable size into space. That was a precursor to India's long and exciting journey into the heart of the unknown. Since then, ISRO has systematically expanded its capabilities by launching projects with specific visions and goals. In 2008, ISRO launched its first planetary exploration with Chandrayaan-1, which lasted 312 days. The mission conducted studies to comprehend the nature of the lunar crust and the evolutionary history of our beloved satellite. It was in 2013 that ISRO turned its attention on Mars. Mangalyaan, India's Mars orbiter mission, completed 4 years in its orbit around the red planet. In fact, the story of the mission became so popular that it inspired a Bollywood film. Within 2 years, ISRO was ready with its next mission, Astrosat. As India's first dedicated multi-wavelength space observatory, it is fully enabled by a single satellite. ISRO's next significant stride into space was Chandrayaan-2, a complex mission to explore various facets of the moon. The Sun is another fascinating point of interest as it rules the movement of the Earth and other planets. With this in mind, India's upcoming Aditya L1 mission will study the Sun's upper atmosphere. India's space odyssey continues, emboldened by the many firsts for ISRO in the last decade. With Chandrayaan, Gaganyaan and other future missions, the aim is to deepen our understanding of the universe and our place in it. In line with the global agenda, ISRO will lead India into the next decade through expanded research and technology development to build future capabilities in space exploration. In the words of Dr. Vikram Sarabhai, we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. Today, as we continue to launch 1 billion dreams, the sky is no longer the limit for India.
ISRO Achievements. The saga of the Indian satellite began with Aryabhatta, the first Indian satellite, from a simple spin-stabilized satellite in the low Earth orbit to the highly complex interplanetary missions. The evolution of the Indian satellites in the last 5 decades has been phenomenal and astonishing. Today, India is one of the pioneering countries to use satellites for its rapid overall development. It has been a challenging and interesting journey over the years, with an array of satellites for communication, meteorological, remote sensing, navigation, scientific satellites, and when it comes to rockets like SLV, ASLV, PSLV, GSLV and GSLV Mark III. These satellites and rockets have been built by different ISRO centers. India has joined an elite space club by launching Mars Orbiter mission in 2013 and made India the first nation to succeed in its maiden attempt to reach Mars. Another feather in ISRO's cap was added when the constellation of 7 satellites created India's very own satellite navigation system. On February 15, 2017, ISRO created history and a world record by successfully launching 104 satellites on a single mission, PSLV C-37. On November 14, 2018, ISRO successfully launched GSAT-29 from Sriharikota. The satellite weighing at 3,423 kilograms, it was the heaviest satellite to be launched by GSLV from Sriharikota. Keeping with India's emergence as an economic and technological powerhouse, ISRO is now working towards manned flight. Many technologies were demonstrated as a precursor to the first manned mission. The experimental mission that paved the way for human spaceflight mission was the Space Capsule Recovery Experiment conducted in January 2007. After the successful launch of Chandrayaan-2 on board the Mark III M2, ISRO now boasts an operational heavy lift launcher capable of putting a 10-ton spacecraft in lower Earth orbit. The maturity gained over the years in the launch vehicle area will be gleaned to engineer a human-rated GSLV Mk3 vehicle worthy of human spaceflight. ISRO is also taking the industry on board for increasing the capability to become a global hub for the space industry. With more than 108 satellites and 77 launch vehicle missions, ISRO has proved to the world that India is second to none in the application of space technology to the real problems of man and society.
The sky has been an object of curiosity and wonder since time immemorial. For thousands of years, astronomers across the globe have studied the movement of celestial objects. It's largely owing to their discoveries that we began to understand our universe. In India as well, astronomy has been a field of study for centuries now. India first ventured into space in the early 60s. When Dr. Vikram Sarabhai laid the blueprint of the Indian space program. It focused on the use of space technology for the benefit of the common man. With the deployment of PSLV, it was now possible for India to launch a payload of reasonable size into space. That was a precursor to India's long and exciting journey into the heart of the unknown. Since then, ISRO has systematically expanded its capabilities by launching projects with specific visions and goals. In 2008, ISRO launched its first planetary exploration with Chandrayaan-1, which lasted 312 days. The mission conducted studies to comprehend the nature of the lunar crust and the evolutionary history of our beloved satellite. It was in 2013 that ISRO turned its attention on Mars. Mangalyaan, India's Mars orbiter mission, completed 4 years in its orbit around the red planet. In fact, the story of the mission became so popular that it inspired a Bollywood film. Within 2 years, ISRO was ready with its next mission, Astrosat. As India's first dedicated multi-wavelength space observatory, it is fully enabled by a single satellite. ISRO's next significant stride into space was Chandrayaan-2, a complex mission to explore various facets of the moon. The Sun is another fascinating point of interest as it rules the movement of the Earth and other planets. With this in mind, India's upcoming Aditya L1 mission will study the Sun's upper atmosphere. India's space odyssey continues, emboldened by the many firsts for ISRO in the last decade. With Chandrayaan, Gaganyaan and other future missions, the aim is to deepen our understanding of the universe and our place in it. In line with the global agenda, ISRO will lead India into the next decade through expanded research and technology development to build future capabilities in space exploration. In the words of Dr. Vikram Sarabhai, we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. Today, as we continue to launch 1 billion dreams, The sky is no longer the limit for India.
ISRO Achievements. The saga of the Indian satellite. ISRO Achievements. The saga of the Indian satellite began with Aryabhatta, the first Indian satellite, from a simple spin-stabilized satellite in the low Earth orbit to the highly complex interplanetary missions. The evolution of the Indian satellites in the last 5 decades has been phenomenal and astonishing. Today, India is one of the pioneering countries to use satellites for its rapid overall development. It has been a challenging and interesting journey over the years, with an array of satellites for communication, meteorological, remote sensing, navigation, scientific satellites, and when it comes to rockets like SLV, ASLV, PSLV, GSLV and GSLV Mark III. These satellites and rockets have been built by different ISRO centers. India has joined an elite space club by launching Mars Orbiter mission in 2013 and made India the first nation to succeed in its maiden attempt to reach Mars. Another feather in ISRO's cap was added when the constellation of 7 satellites created India's very own satellite navigation system. On February 15, 2017, ISRO created history and a world record by successfully launching 104 satellites on a single mission, PSLV C-37. On November 14, 2018, ISRO successfully launched GSAT-29 from Sriharikota. The satellite weighing at 3,423 kilograms, it was the heaviest satellite to be launched by GSLV from Sriharikota. Keeping with India's emergence as an economic and technological powerhouse, ISRO is now
Check. Initiate recording.
Dibyendu, everybody is in, so you can start whenever you want.
Confirm. All mics in the control room to be muted now. Confirm. I now request the Chairperson, Local Organizing Committee of the 21st National Space Science Symposium, Professor Dibyendu Nandi, to take the stage and moderate the inaugural ceremony.
Good morning and a warm welcome to all participants. No, my link is down here. Okay, I lost the link for a little bit, so I'm back now, it seems. Good morning and a warm welcome to all participants for the 21st National Space Science Symposium. Our proceedings are being live streamed for the benefit of all citizens of India. It is my pleasure to present to you our special guest of honor for this inaugural ceremony. We have with us Shri S. Somanath, Chairman, ISRO and Secretary, Department of Space, Shri A.S. Kiran Kumar, Chairperson, National Organizing Committee, Shri Madhavan Rajeevan, Distinguished Scientist, Ministry of Earth Sciences, Shri R. Umamaheswaran, Scientific Secretary, ISRO, Shri Shantanu Bhatawdekar, Director, Earth Observation and Applications and Disaster Management Support Program, ISRO. Shri Arvind Natu, Chairperson, Board of Governors, IISER Kolkata. Srimati Tanushri Shah Dashgupta, Director, Asian Bosch National Center for Basic Sciences, and Shri Sourav Pal, Director, IISER Kolkata. Thank you for your presence in today's program. Professor Sourav Pal, I will now request you to take the stage. Professor Pal is the Director of the Indian Institute of Science, Education and Research, Kolkata. He was formerly the Director of the CSR National Chemical Laboratory, Pune, where he worked for over 3 decades and was instrumental in setting up the electronic structure theory group. He was also a professor of chemistry at IIT Bombay before moving to IISER Kolkata. He is a distinguished theoretical chemist, has more than 250 publications, has supervised 45 PhD theses, and has served in various leadership capacities in national and international organizations. Professor Pal's awards and honors include the Shanti Swarup Bhatnagar Award, the Sastra Sina Rao Award, a J.C. Bose National Fellowship, and the Humboldt Fellowship. He is a Fellow of the Indian Science Academies and the Royal Society of Chemistry. Professor Pal, the stage is yours. Professor Pal, the stage is yours.
Thank you very much, and good morning and welcome to all of you. Chairman ISRO and Secretary of the Space Science, all distinguished delegates and guests. It's a great pleasure for me to welcome you on behalf of the Indian Institute of Science, Education and Research, Kolkata. This is the 21st edition of the National Space Science Symposium, which is the most important gathering of the space scientists, astronomers, solar and planetary scientists, and Earth system scientists in this nation. It is our privilege to host this symposium, or this particular edition of the symposium this year. This symposium is being sponsored by, of course, Indian Space Research Organization, ISRO, S.N. Bose National Center for Basic Sciences, as well as IISER Kolkata. I understand there has been a significant interest in this meeting with more than 2,000 registrations and about 500 abstract submissions. The ISRs were founded by the Ministry of Education, Government of India, to synthesize undergraduate and postgraduate teaching and research under one umbrella to inculcate the spirit of scientific pursuit in India's generation at an early stage. IISER Kolkata is one of the first 2 ISRs to be established in 2006 along with IISER Pune, and has already made a mark in the national and international scenario. We have 5 departments and many centers catering to both basic and focused areas of advanced research. Our main degree at present is the 5-year BSMS, integrated PhD after BSc, and of course the normal PhD program. We also have 2-year MS program in the space science, which is conducted by our Center for Excellence in Space Science, which is actually organizing this symposium on behalf of IISER Kolkata. In this context of the symposium, I'm very happy to note that IISER Kolkata is the only organization in the IISER system to host a dedicated center for space sciences. The SESI, which is our center, is a multi-institutional center involving affiliate and many faculty from many organizations. The center runs MS and PhD programs, as I said, focusing on astronomy, astrophysics, and space sciences, and has been making outstanding contributions to the fields of solar, stellar, and planetary astronomy, gravitational wave astronomy, and space weather modeling and predictions. We are involved in mega projects and missions of national importance, such as the LIGO India project, the Aditya L1 space mission, and so on. IISER Kolkata is also a co-investigator institution in ISRO's Aditya L1 mission, India's first space-based solar observatory currently under development, providing an opportunity for our students, faculty, and engineers to get involved in various aspects of space instrumentation development. We are planning a space optics instrumentation facility as a collaborative effort between the experimental physics faculty and the astronomers to design and develop novel instruments to support the Make in India initiative. I must emphasize the importance of human resource development in this context and our contributions to the same. Apart from our general basic science programs, which have been performing quite well, I'm glad to note that the undergraduate students trained at this Center for Excellence in Space Sciences have acquired PhD positions in places like Caltech, Stanford, and Princeton, among other reputed universities around the world. Our space science PhD students are getting global recognition, such as the PhD at Large Prize of the International Astronomical Union, the Best Thesis Prize from the Astronomical Society of India, and very recently, the Best Thesis Award of the Indian Laser Association. They have secured research positions not only in reputed global organizations for postdoctoral research, but are also contributing to private enterprises such as the TCS Research Wing. Our successful experience shows that with the support and our well-established astronomy and space science organizations, newly established academic institutions such as ISRO have the ability to make a mark in the domain of astronomy and space sciences. I hope with further encouragement and support from ISRO, we can involve more and more students and our younger generation in space sciences initiatives of importance to the nation. On behalf of IISER Kolkata, my colleagues, and the extended community of IISER, I wish you a very successful and productive symposium. And I thank all those who have contributed to a very smooth organization of the symposium. And I'm sure all of you will enjoy the deliberations in the next few days. Thank you very much.
Thank you, Professor Pal. I now request Shri A.S. Kiran Kumar, the Chairperson of the National Organizing Committee of the Symposium, to take the stage. Kiran Kumar is the Vikram Sarabhai Professor at ISRO headquarters and the Chairperson of the Symposium. He has previously served as Secretary, Department of Space and Chairman ISRO. Shri Kiran Kumar has steered the implementation of the applications-oriented Indian space program, led the design and development of more than 50 electro-optical imaging sensors flown on various spaceborne platforms, starting from the Bhaskara mission. His role has been instrumental in the successes of the Chandrayaan and the Mars orbiter missions. Shri Kiran Kumar has co-authored 85 publications. In recognition of his contributions, he was conferred Padma Shri by the President of India in 2014, the Rajya Sabha Award and Sri M. Viseswariya Senior Scientist State Award by the Government of Karnataka, and the Chevalier de l'Ordre National de la Région d'Honneur, the highest civilian honor of the Government of France. Shri Kiran Kumar, the stage is yours.
Thank you, Dibyendu. And at the outset, let me welcome all of you for this 22nd National Symposium on, 21st National Space Science Symposium, which started way back in Varanasi, the first symposium. We are indeed thankful to Dr. Somanath, Secretary, Department of Space, Dr. Umamaheswaran, then Dr. Sourav, and all the dignitaries on the stage. And what this National Space Science Symposium is providing an opportunity for the community, space science community in the country. And today we have seen almost 29 invited talks being organized as part of this program and 228 oral presentations planned, and number of poster presentations including flash is about 236, and this is being organized as in a virtual mode, which is actually a fallout of the COVID, which has actually made a huge impact on the society and nations across the globe. And what this has also shown is the new way of dealing with things can be beneficial in many ways. We can bring in a large number of people across the country on a common platform and give them an excellent platform to interact with each other. And what we are seeing in this particular program is a set of key disciplines: space-based meteorology, oceanography, geosphere, biosphere interaction, then middle atmosphere, atmospheric coupling, dynamics and climate change, solar and planetary sciences, astronomy and astrophysics, enabling technologies for space exploration are all part of the deliberations that are going to happen. The whole idea of this kind of a annual symposium that is being organized is to bring to the people across the country what developments are taking place in the country in this area of space technology and space-based observation, both space for Earth and space for space. And in this context, bring in the new younger generation and provide them an opportunity to showcase what they have done and also learn from others. So let me compliment IISER Kolkata and particularly the team under Dibyendu and his student group who are getting to know in an experiential learning manner the process of learning things. In fact, it is very important today. Even the new education policy emphasizes what is required is to understand more the process of doing things than the content itself. So in this context, this opportunity for the students of IISER to conduct a huge program of this kind and bringing in researchers, research community. And one of the key things that we need to take forward as a part of this symposium is how to make this not just a event of few days, but an event which is actually year long and then contributes to the progress and growth of both planning and conducting experiments in the future. And I'm sure things are planned both in terms of outreach, reaching out to the younger and even school level students, and then bring in them an awareness of the kind of things that are happening in the country, the kind of progress that the country is making. I'm sure you will hear more during the course of subsequent talks. So let me compliment IISER Kolkata and Nandi ji for taking the actual burden of conducting this event in the period of COVID and then making it happen in a very lively manner. So wishing all of you a great couple of days of interaction, and thank you very much for participating in this program. Thank you.
Thank you, Shri Kiran Kumar, for your very encouraging words for us. I now request Shri Umamaheswaran, Scientific Secretary ISRO, to take the stage. Shri Umamaheswaran is presently the Scientific Secretary and Distinguished Scientist at ISRO headquarters. He is a domain expert in the field of launch vehicle system electrical integration, checkout, ground station avionics systems engineering, and space policy planning. In his current capacity, he is responsible for the overall policy, planning, and programs of ISRO. He has played significant roles in drafting the sectoral reforms in space towards the Atmanirbhar Bharat vision and in drafting the Space Activities Bill. Shri Umamaheswaran plays a leadership role and represents India in many international and national bodies of engineering and sciences. He has won several awards, including the ISRO Individual Merit Award, ISRO Team Awards, and the ISRO Outstanding Achievement Award, and the ASI ISRO Award. Shri Umamaheswaran, the stage is yours.
Thank you. Am I audible?
Yes, you are audible.
Respected Sri Somanath, Chairman ISRO and Secretary Department of Space, Sri A.S. Kiran Kumar, former Chairman ISRO and Chairman of the National Organizing Committee of NSS 2022, Dr. Rajeevan, ex-Secretary, Ministry of Earth Sciences, Professor Sourav, Director IISER Kolkata, Professor Dibyendu Nandi, the Chairperson, Local Organization Committee, distinguished members of the National and Local Organizing Committees, members from the academia, institutes, industries, and my dear colleagues. A very good morning to one and all. At the outset, let me share my best wishes to the organizers of NSSS 2022 for organizing this event. National Space Science Symposium has always been the platform for space scientists to exchange the scientific results and review the lessons learned from the ground and space-based observations. I understand that NSSS was due in 2021, but it could not be conducted due to the disruptions caused by the pandemic. However, the good part is that this year's NSSS is going to have a few innovative aspects like a significant component of space science outreach program wherein the students are roped in to participate in various competitions. Unlike previous years, this year's program will not be over in 4 or 5 days. There is a plan to organize the in-person mode of science outreach in Kolkata when the pandemic condition improves, wherein there will be space exhibition, interactions with students and public, popular lectures, and many more. In addition to these, there is a plan to keep the enthusiasm sustained by organizing fortnightly or monthly public lectures on space sciences in virtual mode, which will start after the completion of these 5 days of events and continue till the in-person science outreach events. Unlike the previous symposiums, in this year's 21st symposium, there is a dedicated session for enabling technologies for space exploration. It was a well thought and well appreciated move. In fact, I say that it is the need of the hour to bring the space technologists and the space scientists on the same platform to integrate the capabilities towards the materialization of the space vision. I congratulate the national and the local organizing committees to have taken such a very innovative and bold decision. Another important decision taken by the organizers is that they have planned to transform this NSSS to a vehicle that will, in addition to its granted mandate of exchanging scientific results, also contribute systematically to human resource generation in space science and technology. There will be a connection between one NSSS to the next, wherein it will be a process-driven activity to regularly nurture the students on various aspects of space science. I congratulate you for this very innovative thought. At this juncture, I full-heartedly support all your efforts and ventures to bring out the best possible science and human resources through this symposium. Thank you once again for this revolutionary thinking, unconventional working, and long-term planning, and thereby addressing the need of the hour. Thank you once again for giving me an opportunity to participate in this event. Jai Hind.
Thank you, Shri Umamaheswaran. May I now request Shri S. Somanath to take the stage. Shri S. Somanath is a distinguished scientist and the Secretary, Department of Space, Chairman, Space Commission, and Chairman ISRO. Spanning a distinguished career of nearly 36 years, he has made significant contributions to the areas of space technology. In his previous assignment as Director, Vikram Sarabhai Space Center, he was responsible for the technology development of launch vehicles. Under his leadership, VSSC achieved significant feats like crew escape system demonstration through pad abort test and the launch of GSLV Mark III M1, which ferried Chandrayaan-2. He is spearheading the upcoming Gaganyaan mission and the development of SSLV, India's small satellite launch vehicle. Prior to these positions, Shri Somanath was the director of the Liquid Propulsion System Center, where he oversaw the development and qualification of CE-20 cryogenic engine and the C-25 stage, which was successfully flown in GSLV Mark III D1 flight. In his capacity as the Associate Director, Projects of Vikram Sarabhai Space Center and Project Director of GSLV Mark III launch vehicle,
the first experimental flight of LMV-3X air mission was successfully accomplished. Sri Somanath has published several papers in journals and seminars in the area of structural dynamics and control, dynamic analysis of separation mechanisms, vibration and acoustic testing, launch vehicle design, and launch services management. Sri Somanath is a fellow of the Indian National Academy of Engineering, the Aeronautical Society of India, the Astronautical Society of India, and is a member of the International Academy of Astronautics. Sri S. Somanath, on behalf of the organizing committee and the local hosts, it is my pleasure to request you to inaugurate the 21st National Space Science Symposium and make your inaugural remarks.
Thank you, Dr. Dibyendu Nandi, Chair of the Local Organizing Committee, for the introduction. Most respected Shri A.S. Kiran Kumar, the former Chairman, ISRO, Secretary, Department of Space, and Chairman of the National Organizing Committee of Nsss 2022. Dr. Rajeevan Madhavan, former Secretary of Ministry of Earth Sciences. Professor Sourav, Director, IISER, Kolkata. Shri Umamaheswaran, Scientist Secretary of ISRO. Shri T.P. Das, Director of the Space Science Program Office. Distinguished members of the national and local organizing committees, members from academia, institutions, industries, and all my colleagues. My greetings to you on the occasion of the inaugural function of NSSS 2022. At the outset, let me express my happiness to note that this National Space Science Symposium, which is organized in alternate years and which was due for 2021, is now finally occurring now. The NSSS 2022 is being organized quite differently as compared to the previous occasions. And there is a lot of outreach activity this time, as already been mentioned, with the participation of students and people of different age groups. Really welcome step. So let me congratulate for all that wonderful organizing part of that has been done by all. And especially, I would like to congratulate the host institute, IISER Kolkata, for having this time NSSS 2022. As you are aware, the space science research was one of the primary driving force of the Indian space program. And also this activity started very early. We started with the sounding rocket launches to understand and explore the upper atmosphere aspects. Then slowly, with the capability that came from the sounding rockets, came the launch vehicles, which again grew in size and capability to lift heavier and heavier satellites. Also, we increased the launch frequencies, capabilities, and also put large number of partners in building this. Has been really developed both internationally as well as domestically for carrying out missions which has specific science content in it, in addition to the applications that we already know. Having paved way for such long 66 years, having graduated from sounding rocket experiments to very focused scientific experiments on board satellites, today Indian space program aims at understanding and exploring the entire solar system, maybe beyond that also. In this endeavor, the space program defines conducting space science mission, engaging with academia and industry, as well as promotes international cooperations for advancing knowledge and its capabilities. The objective of the space exploration is quite noble. You all realize that it is not an investment that is expected to yield immediate returns. Like the applications missions or even strategic applications like communication, remote sensing, disaster warning, etc. But investment in specific space science exploration has a bigger goal, like gaining scientific knowledge on the past and the present state of the solar system, the cosmos, and to predict our future of the state of Earth as well as other planetary bodies, and also to expand human presence in other planets as an alternate abode for the sustenance of the human race, to answer outstanding problems of the origin of life and extraterrestrial intelligence, if any. In ISRO, we know that we have been very keenly working on various missions, like the successful mission of the Chandrayaan-1, the Mars Orbiter mission, the Astrosat, and we have clearly demonstrated an end-to-end capability to plan and execute such major scientific missions. In Chandrayaan-1 and Astrosat, ISRO enabled quite large amount of opportunities to the contributions from international collaborative agencies and also national institutions of science for hosting science payloads and exploring and using the data from this for furthering research. India contributed to a better scientific understanding of the moon, Mars, and astronomical objects through successful space-based missions of Chandrayaan 1 and 2, Mars Orbital Mission, Astrosat. Missions to Moon and Mars also include studies on surface morphology, composition, atmospheric structures, and the dynamics and solar interaction processes. The Astrosat mission endeavors for a more detailed understanding of our universe through multi-wavelength observations, which is very unique. The scientific findings and discoveries have opened up many new scientific problems and demands for further exploration and studies. In pursuit of space exploration in general, the space science program envisages mission leading to the understanding of Earth atmosphere, the ionosphere, thermosphere, magnetosphere interactions leading its way up to the moon and its neighboring planets like Mars and Venus. Also looks at other planetary bodies, including comets and asteroids, and eventually extending the study of the exoplanets and also astrophysical processes. In this pursuit, India's quest for space science and exploration are driven by a set of fundamental facets and questions like the Earth atmosphere system and the connections with the Sun, the connection of Earth with other members of the solar system, leading to the understanding of the origin and evolution of the solar system, insight into the space weather, which would throw light on the connections of the Sun with the solar system objects. How does the solar system connect the rest of the universe? The enigma of the life beyond planet Earth and its link with the origin of life and the sustenance of life beyond planet Earth. The problems are understanding the journey is challenging. Scientifically, the bigger problem is split into multiple problems with specific questions to answer, which in turn guides the definition of space missions and the ground-based observations. In this journey from most fundamental level to the specifics, it is understood that the scientific community need to address space science holistically. So when I say address the space science holistically, I mean that all the components of the perceivable space like the Earth, the Sun, the planets, the natural satellites, the small bodies of the solar system like asteroids and comets, the astronomical sources, the solar system of giant galaxies and exoplanets all need to be studied with individual importance, as well as their connections needs to be explored. After all, nothing is isolated in this macrocosm. It's a giant web of interconnectedness that makes space a wholesome, and studying space and its components should lead to the holistic understanding. Here lies a speciality of the National Space Science Symposium. The symposium would address multiple facets like Earth system science through space-based meteorology, oceanography, geosphere-biosphere interactions, dynamics of the middle atmosphere, atmospheric coupling and climate change, science of the sun and solar system, extending to the astronomy and astrophysics. What I further understand is that in this year's NSSS, there is a dedicated session on enabling technologies for space exploration, as Mr. Umamaheswaran has already explained. This is indeed an innovative idea because one needs technologies to materialize the big dream of space exploration. At this juncture, the NSSS provides a platform for the connectedness of the community, where the group of scientists who are active in their respective domains of research, the group of teachers who are imparting the knowledge to students, the students who are fascinated by the enigma of space, some of whom are going to build career in space science. It's not only one who will build the career in space science, it includes the students who see space as a subject of humanity through the lens of aesthetics, the mystery, and source of creative inspiration. NSSS includes all these people under one umbrella. It's really wonderful to see that. NSSS is not only to review the scientific outcome from various previous space missions and also plan for the next set of observation missions, but well beyond. The Space Science Symposium is expected to catch minds younger than creative thinkers, scientists, engineers, artists, and philosophers. The competitions like quizzes, lectures, all these components are there in this endeavor. The popular science lectures, interdisciplinary lectures, invited lectures, all are chosen, as I could see, to give this bigger vision in this mind, in their mind. At this juncture, I must thank the guidance provided by Shri A.S. Kiran Kumar, who motivated the whole team of organizers to work towards such a very detailed program. I also understand that because of the pandemic situation in this country, the in-person mode of scientific outreach is temporarily put on hold, and there is a plan to host a scientific outreach component of this program in person in Kolkata in summer, hopefully when the situation becomes much better. And also to keep the enthusiasm ongoing, the organizers are planning to have programs of lecture series of mostly semi-popular and popular lectures, which will be conducted maybe fortnightly in the coming days. So finally, let me wholeheartedly bless the whole of this team, especially from the Science Program Office, ISRO, and all from IISER Kolkata, the host organization, and all the local organizing committee for making such a wonderful effort to make this NSSS 2022 happen. And I believe this effort will really create the much needed human resources in the field of space science. Let me also wish at this moment very best for the remaining few days for very good interaction, and finally to create once again the great amount of enthusiasm among the researchers in this country to create more interesting space science mission through the vehicle of space. Thank you so much, and let me also declare the NSSS 2022 inaugurated.
Thank you, C.S. Somanath, for inaugurating the symposium and declaring it open. I now request Dr. Tirtha Pratim Das, Director, Science Program Office, to moderate an interaction with the Chairman, ISRO. Tirtha, the stage is yours.
Thank you, Dr. Dibyendu. Good morning to all the respected dignitaries here, and welcome respected Chairman, ISRO Secretary, Department of Space, Dr. Somanath sir, to this interactive session. Sir, the National Space Science Symposium is currently being watched online by thousands of participants spanning the students, researchers, as well as active space scientists of the country. The audience is very happy to have you, respected sir, in this forum for interactions on ISRO Department of Space's views on space science research and exploration. In view of ISRO's success in space science explorations and the roadmap thereof, the audience is eagerly waiting for this interactive session. With your kind permission, sir, may I start the interaction session?
Yeah, please go ahead. You can make it very brief, and we can also seek any specific questions to be answered by our eminent scientists who are also there in the panel, not only me. Yeah, you can go ahead. Yes.
Thank you, sir. So to start with, would Chairman ISRO like to tell the audience about the role of space sciences, to be specific, in the genesis of the Indian Space Research Organization?
See, Sridas, I have already mentioned in my inaugural talk that we started with some of these space science as one of the key drivers of space exploration. Early part of the program that we started in ISRO, like understanding the atmosphere through the sounding rocket mission was one of such an activity. You realize that when we came to Tumba, the geomagnetic equator, was chosen as the place for starting the rocket program. But along with that, the space rods were being built, and there were science experiments hosted in some of those satellites like the Aryabhatta and Bhaskara and the Sourav series, even IRS P3 and GSAT-2O. Many of them were hosting science payloads. So this was the beginning of the work which we did at the early part of the space research. And through this process, it actually created a group of space scientists, really, the true sense, who actually worked on the fundamental issues and then conducted research in various places across ISRO, at Ahmedabad in PRL, Space Application Center, URSC, as well as in Vikram Sarabhai Space Center, as well as other institutions in this country, who have the keen interest in working in space research specifically, which later paved way for creating instruments, etc., on board our future missions to the space.
Thank you very much, sir. When we interact with students and learned community, even the school kids, they all are interested to know about the different domains covered by the Indian space program. Would Chairman kindly tell about the domain of the space program once again in this introduction session?
It's okay. To state the same thing in a different manner. Basically, see, it's already been mentioned that we need to understand space science in its entirety, starting from the connectedness of the place where we live, our planet Earth, and how the understanding of the science related to this is actually going to decide your survival here. And also the day-to-day life of us are very well connected to this. So we need to understand the dynamics of this interaction which takes place between Earth and other bodies, primarily the sun, the energy giver, and the atmosphere, and the geosphere, the magnetosphere. All these interactions become very important. So it's very, very essential part of the study. We also have to study the planetary bodies because now we, as mentioned, that the human race cannot continue to remain in this planet. It has to spread its wings to beyond Earth also. So, and space technology being the only vehicle through which that we can access these planetary bodies physically and remotely, either way, through instruments. So understanding them through this is yet another domain of space science. And of course, no, we also become part of the global community trying to understand the entire cosmos in its entirety. There are interest groups in this science community who are conducting fundamental research on this aspect as well. So through the limited capability that we offer in terms of the astronomical observatories in ground as well as in space, we also contribute to the science of this part as well. So these are the three multiple domains where we work in general terminology.
Thank you, sir. As Chairman ISRO has mentioned, that in the process of understanding the space science in its entirety, one of the important facets is planetary science. And when we speak about planetary science, the first celestial object which catches our attention is the Earth's moon. And would Chairman ISRO in this forum be pleased to tell about the Indian Lunar Science Exploration Program?
See, moon is something very interesting. It has been well studied by many other nations through their exploration. But when you talk about Indian knowledge, Indian awareness about moon has been very limited. And it all started with the conceptualization of Chandrayaan-1 and the moon impact probe at that point of time. And the objective of that Chandrayaan-1 study was to understand the surface topography of the moon, the mineral and the elemental distribution, study the volatiles, and search for, for example, the subsurface ice, maybe the water hydroxyl molecules, and observation of that. Now, all this was really done, and we also realized that we dropped the first of the probe on the surface of the moon, and the detection of the water on the sunlit lunar exosphere was also so. This was one of the important findings that we achieved in Chandrayaan-1. Then we had the Chandrayaan-2 with an orbiter, lander, and rover, and all of you know that the landing attempt was not successful, but the orbiter is continuing to work there for many long periods, and it is giving a lot of science data. Some of them include the highest resolution image from lunar orbital platform, something like the elemental maps in the extended IR region, the first L-band operation on the moon, etc. And also Chandrayaan-2 helped in unambiguous detection of the water ice signature from the IR spectrometer. We are also further working to enhance this through the Chandrayaan-3. We hopefully will land with this time with the Chandrayaan-3 orbiter and lander experiment. And probably this experiment has much more things that which we couldn't achieve in the last mission, like understanding the nature of the surface, its conductivity, and various other parameters that we want to measure it. So this is something that we need to continue to understand as our natural planet is, in addition to Earth, we need to create continuous program to probe and understand moon for the future. And in this process, we will also look at how we can rope in other partners in creating more science missions in the future.
Thank you very much, sir. So speaking about moon once again, the recent mission to moon, Chandrayaan-2, has really created a lot of interest, not only in the scientific community, but also to the community who are yet to take space science as their career. So the community keeps on asking, the orbiter having been in orbit for a couple of years with so many sophisticated instruments, what all science results have come so far. So would Chairman tell something to the audience about the scientific outcomes so far from the Chandrayaan-2 mission?
No, here the one of the important finding, as all of you realize, that the detection of the lunar hydration absorption feature around 3 micrometer at all latitude and surfaces, and also subsurface water ice deposits in the Cabeus crater at the lunar south pole using powerful dual frequency full polarized synthetic aperture radar experiment. Then another is a neutral mass spectrometer for the first time provided global distribution of argon 40 in the lunar exosphere. Detection of large number of microflares occurring outside sun's active region due to the coronal heating problems. These are some of the very interesting scientific findings, and quite a large number of publications also came out of this Chandrayaan-2 measurements and data.
Thank you very much, sir. And going beyond the moon, the first interplanetary mission of ISRO has been the Mars Orbiter mission. May Chairman ISRO kindly tell this audience who may be eager to know the status of the Mars Orbiter mission?
See, all of you know that it was originally destined to stay in orbit for only 6 months, but now, past September 24, 2021, it has completed 7 years. Really a wonderful feat as far as MOM is concerned. And it has still beaming the scientific data and produced more than 35 publications from the data from Mars Orbiter mission in peer-reviewed journals. It is really wonderful to have so much of scientific outcome from a simple mission which lasted many years.
Thank you, sir. This is indeed encouraging, and many people will take up not only the science of the planets, also the instrumentation aspects, I'm sure. Now, sir, going beyond this planetary science, ISRO has also done some significant work and got some achievements in the field of astronomy. And Astrosat is known as India's multi-wavelength observatory in space, is Chairman ISRO has mentioned during the inaugural session. So may Chairman, sir, kindly brief on the major scientific accomplishments of Astrosat mission.
See, Astrosat is one of the most important India's contribution to understand the universe, like the great Hubble, the Chandra, though they are not of the class, but it has specific, very important, interesting feature like the multi-wavelength observatory capability, which is very unique. So let me say a few points. One is the discovery of the UV photons from a galaxy which is 9.5 billion light years away. Really, this is one of the interesting findings. And it also revealed that the famous butterfly nebula is much bigger than as seen in the visible light, almost 3 times bigger. And it also solved one very interesting decade-old puzzle of a star bright both in UV as well as in IR by discovering a hidden white dwarf. No, all this may appear to be very simple, but then it is a capability that is unique to this the Astrosat that enabled these findings to really come out.
Thank you, sir. Just to take you from your response, the Astrosat is a mission which is driven by the community. All the astrophysicists of the country, they have joined hands to build this observation platform. And after seeing these good scientific outcomes, there has been a lot of motivation to carry this forward. So motivated by the success of this Astrosat, can Chairman kindly tell the plan of ISRO for follow-up of this Astrosat mission?
Thus, in this matter, we are still under discussion, and various instrument discussions and proposals are there. Probably at this moment, I will not go into what exactly are the specific nature of those missions. It will definitely be brought out and consulted with scientists in the due course of that.
Thank you, sir. Apart from the planetary science mission and astronomy mission, ISRO is gearing up for its first Heliophysics Observatory, Aditya L1. Could Chairman, sir, kindly enlighten about the significance of the mission?
Aditya L1 has already been brought out in the public in great detail. And this is the first space-based Indian mission to the study of Sun. And we are going to move the spacecraft and place it in the Lagrangian point L1 of the Sun-Earth system. and which is almost 1.5 billion, million kilometers. Sorry, made a mistake. It's 1.5 million kilometers from Earth. And it will be halo orbit around this L1 point. So this gives us an advantage of observing the sun for very continuous, without any occultation or eclipses. So this is specifically the way in which the satellite will be placed. And it also looks into the activities in sun, like solar activities, and how it affects the space weather as far as Earth is concerned. So it also has various payloads which are crucial to understand these problems like coronal heating, coronal mass ejection, pre-flares and flare activities, their characteristics, the dynamics of space weather, and propagation of particles and fields. So all these instruments on board Aditya L1 will make us understand the connection between Earth and Sun in much greater detail. It's more on study of Sun, but how Sun affects Earth, and that is what is the key drive.
Thank you, sir. So, as Chairman sir has mentioned, that the interconnectedness of the Sun and Earth, the other solar system bodies also will be studied, which we call the space weather and its impacts, which will be studied by Aditya L1 mission. Sir, in this context, another question which our audience would like to know, that ISRO has a roadmap for its space science exploration missions. So in view of this, how may the academia and institutes be a part of the Indian space science exploration program?
I believe that it has to be much a stronger partner. The first thing, as you mentioned, that we need to create that required capacity within all these places to really to create the interest and also to create the research interest. Second is whatever data that you are able to create, bring it from these missions. It must be used for to study, to publish, to understand, create new findings. We also need people to ideate new instruments that you can use it for measurements in future science missions. So this is very essential that we need to have partnership with the much more scientific pool of this country to make use of it. The ISRO can do at the best is to engineer and then launch these missions. But then if these missions have to really bring fruits on enhancing knowledge of the humanity, it has to be through the scientists who will a priori plan what all we can do or make use of the data that is already available to create further knowledge. So we expect people coming up with this type of skills in conceiving newer payloads, building new payloads, making use of the science data, and then create more knowledge, and then contribute to the knowledge pool that is globally available. So this is the type of interaction that we are looking in NSS itself to kindle this interest and then contribute to this overall mission.
Thank you very much, sir. And I'm sure the academia and the students, institutes, they are highly encouraged by listening to the chairman's response. And thank you, respected sir, for this simple and quite illuminating interaction. I'm sure the audience is greatly benefited to have listened to Chairman ISRO's words on space science exploration. With your leadership, respected sir, we look forward to more contributions from India to the field of space sciences and exploration, which will take our country to the next level of excellence in this scientific program. Once again, respected sir, I take this opportunity to thank you for your time, your enthusiasm, and kindly agreeing to grace this inaugural session. Jai Hind, and over to Dr. Dibyendu Nandi.
Thank you, Tirtha. May I now ask if any of our guests of honor who are present here has any comment or a question for the Chairperson ISRO? You can unmute yourself and ask a question or make your comments because we still have some time. If not, then I again thank Shri S. Somanath, Chairman ISRO and Chairman Department of Space for his inaugural address and for giving this inaugural lecture and opening this symposium. Thank you very much. May I now request the playing of the National Anthem with which we will close the symposium. I request everyone to please mute your mics. That sound? Is this an issue or no? No, no, that's not an issue.
Thank you all. We request Shri Shantanu Bhatawdekar to take the stage and moderate the popular science lecture to be delivered by Shri Madhavan Rajeevan. A word of caution. If the presenter receives a message saying attendee XXX is requesting control, deny the message or simply ignore, where XXX could be any random name. Shri Bhatawdekar, Shri Rajeevan, the stage is yours.
Most respected Shri S. Kiran Kumar, former Chairman ISRO, Shri Somanath Sir, Chairman ISRO and Secretary, Department of Space, Dr. Sourav Paul, Director IISER, Scientific Secretary ISRO, all the members of the organizing committee, particularly Dr. Dibyendu Nandi and all other committee members. I welcome you all for this particular session. Just to start the session, as we know that the climate change and its impact is a global concern, and several agencies, including ISRO and other departments in India, are working on various initiatives to address it. So the climate change per se requires the better understanding of physical, chemical, and biological interactions that really regulate our Earth system. It also requires understanding the changes which are occurring in the system, including the influence on the climate by the natural forces as well as from the anthropogenic activities. Of course, everyone knows that climate change is a global phenomenon, but we always see the impacts are often local as well. And when it comes to India, things are of course not so simple. We are a tropical country, and there are many topics ranging from the extreme heat waves to the increasing frequency of extreme rainfall over India. There are many questions which people ask, how the changes in the surrounding oceans, as well as from the faraway effects like El Nino affect our Indian monsoon. The Arabian Sea is less prone to cyclone than compared to Bay of Bengal. But will it remain same in the concern because of the global warming and increasing surface temperature? There is also increasing trend in the sort of greenhouse gases. There is alteration in the aerosol properties, which changes their radiative properties and the cloud condensation properties. So these changes also impact the biosphere, which certainly has the feedback on the climate system. So there are many such questions, and all these requires the in situ as well as the space-based observations, analysis of the long-term data, the simulation, and the sensitivity studies with various models. And of course, space really provides the opportunity to map the climate indicators, to monitor the climate change agents, and modeling the climate impacts at large. So, of course, for the today's session, we have no other better person than Dr. Rajeevan, who is a well-known climate scientist of India, and we'll all have the opportunity to really understand from him, who has such a rich experience. And though, of course, Dr. Rajeevan needs no introduction for the global community, and not only for the Indian scientific community, but as a custom, I will just introduce him. Dr. Madhavan Rajeevan is at present working as a distinguished scientist at the Ministry of Earth Sciences, and he has served as the Secretary of Ministry of Earth Science for 5.5 years, from December 2015 to July 2021. Dr. Rajeevan has a master's degree in physics from Madurai Kamraj University and PhD in physics from University of Pune. And during his 38 years of the commendable service, particularly for the weather community, he has worked at many institutions like Tata Institute of Fundamental Research, India Meteorological Department, the National Atmospheric Research Laboratory, and also, of course, served as a brief as a director of Indian Institute of Tropical Meteorology. So you can see the way he has worked across the various agencies and immensely contributed to the climate and the weather studies. Dr. Rajeevan is well known for his significant contributions in the tropical meteorology. He has made research contributions in monsoon variability, the monsoon prediction, the climate change, extreme weather events, mesoscale convective systems, and satellite data applications. During his tenure as the secretary, he started many new initiatives for improving weather and the climate services in the country. And quite recently, we have seen about the mega programs launched by MOES, particularly the OSMART and the Across. He's really has come out of because of his tenacity and the way he's guiding and want to bring a change in the total system, which basically studies the impact of the climate change as well. He has, of course, published more than 150 research papers with an high H index of 51 and around 11,000 citations, which is quite a big number. He also guided 10 PhD students from different universities. Dr. Rajeevan is a fellow of 3 science academies of India and a member of International Academy of Aeronautics. He also served the World Meteorological Organization in many capacities, and at present, he's also an expert on the research board of WMO. So I will not take much time with this. Dr. Rajeevan, I invite you to deliver your talk and enlighten the audience. Thank you very much.
Thank you. Can you just put on? Can you start the presentation? Yeah. So good morning to all of you, and first of all, thank you very much for a nice introduction, and thank you very much to ISRO as well as IISER Kolkata, especially Dr. Nandi, for giving me to present this, give this important presentation on climate change and Indian perspective in this inaugural session. Thank you very much. So I'll be basically talking about what do you mean by climate change and what are the concerns from the Indian perspective. And I'll be giving since it's a popular lecture, I'll be basically presenting the details in a very simple language so that all people can really understand what you mean by climate change and what are the impacts on Indian region. So thank you, and also I would like to thank Dr. Kiran, my colleague at MOES, for giving me a lot of materials for my presentation. If we really talk about Earth climate system, it basically comprises of 5 spheres. Atmosphere, which normally, as far as Earth system, climate system is concerned, we are worried about 30-40 kilometers. Then hydrosphere, which is nothing but water, basically oceans, rivers, lakes, etc. Lithosphere is nothing but solid earth. Biosphere is basically snow and ice, and biosphere. So all these spheres, they are not independent. They basically interact each other. And interact in a non-linear way, such that it's very complex non-linear interaction they do, and everything put together is we call it climate system. And any changes in any component of this system can have really impact on other components, and finally the whole Earth system, the climate system, can really make a lot of changes. And basically, it is all interactive feedbacks, which we understand mostly, but many feedbacks we don't understand fully. And this is a pictorial figure of a pictorial representation of how a climate system looks like. Very simple way, but basically we receive energy from sun. Solar energy is the basic input to which is driving the Earth's climate system. And we have atmosphere, we have cryosphere, we have oceans, we have land, and there is interaction between land and atmosphere, Also, we have interaction between ocean and atmosphere. And in the atmosphere, we have trace gases, we have clouds, we have aerosols, and clouds precipitate in terms of actual rainfall or in terms of snowfall. And the cloud process is much more complex than what we think. And these are all put together. And then there's a biosphere, the glaciers, volcanic activity. So there are natural activities which is happening every time. For some volcanic activity, it's a natural process, whereas there are a lot of human influences in the climate system. For example, we burn a lot of fuels, which can release a lot of greenhouse gases in the atmosphere, which can really cause a different kind of feedback to the system, which I will be basically talking about. And this is, we saw all basic physics students know that we receive sun solar radiation, and about 1340 watts per meter is solar constant. And when the Earth system receive it, and it should also emit the same kind of radiation out. So it's in terms of long wave radiation. And this two energy has a balance. So it's radiatively this equilibrium is attained. And any changes in this in the energy balance can really offset and can change the global mean temperature. And and how we have the so-called the greenhouse effect in the atmosphere is basically we have an atmosphere in which there are a lot of greenhouse gases. So as I said that 40 watts per meter square solar constant. So the top of the atmosphere about 343 watts per meter square solar radiation reaches. It's a mean value. And it passes through the atmosphere. It has a scattering process. It happens in the clear sky. In the cloud, it has additional scattering from the clouds. Clouds absorb a little bit solar radiation, and half of the solar radiation is absorbed by the land surface. Then land surface emit in terms of long wave radiation. Also, atmosphere also emit in terms of long wave radiation. And 343 watts per meter square, which is received at the top, has to go out in terms of long wave radiation. And some of the solar radiation is reflected back, and it's about 103 watts per meter square. That means 103 divided by 343 is about 0.3. So that's why we call global albedo is about 0.3. 30% is the albedo, global albedo of solar radiation, and 240 watts per meter square in terms of long wave radiation. So there is a clear balance between the incoming solar radiation and outgoing long wave radiation. If any change in the atmosphere process, for example, changes in the greenhouse gas or changes in the atmospheric aerosols can really modulate or change the energy balance, which can ultimately lead to change in the global climate system. So what we are talking about greenhouse gases, the natural greenhouse gases is basically water vapor, which is a natural gas. It's not emitted by human activity. It's a natural process. And carbon dioxide, which is basically the concentration of carbon dioxide increases because of the human activity. Methane, ozone, nitrous oxide, these are all greenhouse gases which can lead to, for example, changes in the climate system. And what are the human activities which we talk about is basically industrialization, especially after 1950s. Deforestation, there's a lot of deforestation is happening everywhere. At public transport, the vehicles, etc. Land use changes, we are making a lot of changes in the land use in terms of agriculture and etc. And many other processes we do every day, which are called human activities, which can cause abnormality in the energy balance. And how we monitor this climate system, Earth's climate system. So we have a so-called global climate observing system. It's maintained by World Meteorological Organization, and so that to ensure the availability of global observations for climate. It's a global system, and it gives all kind of observations, and which is the climate system observations has a different kind of criteria. It's not a typical weather observations. It needs a continuity in terms of long-term observations, and also it has a high quality and fixed number of stations. We need to identify the fixed network for observing the climate change. We cannot use random number of observations for understanding the climate system, because the random number itself can really contribute some kind of abnormality in the time series, and it can cause we can assume that can be climate change. So basically, the observing system should be fixed. So we have so-called global climate observing system, which are identified both at the surface as well as in the atmosphere, and also it has different components. This is basically global observation network, which satellites is playing an important role. Without satellites, the global observing system cannot be complete. And I will tell you, these observations not only being used for observing global climate system, but also being used in the numerical weather prediction for weather forecast as inputs. And if 100 data goes into the numerical weather prediction data model, 90% of the data comes from satellite. So satellite plays a very, very important role. So ISRO is playing an important role in terms of observations, Earth observations, and of course INSAT observations are also available for us to make use of it. And of course we have plenty of other satellite data which are available online, which we can make use of. So there are observations over the ocean, so-called ship observation, drifting buoys, the gliders, and gliders nothing but drones in the atmosphere. So we have the gliders in the ocean. And the land, we have symbol observatories, meteorological observatories, we have wind profilers, we have radio zones, we have aircraft observations, so plenty of observations. All these put together, we have a global observation network. And all this observation network, we assimilate it and we make it a long time series and try to understand how the climate is changing. And I'll start with how greenhouse gases were changing. This is the very important diagram, which clearly shows how last 2000 years or so, how the concentration of carbon dioxide and other greenhouse gases like methane and nitrous oxide have changed. And you can see the sharp rise. And last 2000 years, most of the time, and the observations very clearly show the concentration was almost flat. It's a very, very simple straight line. But the last last 50 years or so, the sharp rise, which is very, very unprecedented. It never happened, this kind of sharp rise in the last, at least for the last 2000 years. You can ask a question how we get the data for some 1000 years back. We have these observations basically from proxy data. It's basically from ice cores we can get it. We can get it in many other aspects. From the oceans we can get it. Antarctica, for example, when we go there, we can drill the ice cores and the molecules, carbon dioxide molecules, etc., are trapped in the air there, and we can analyze it what was the concentration. So these are the proxy observations which we can find out, and we can understand how these greenhouse gases are changing. So last 70 years or so, the unprecedented increase in the greenhouse gases has been observed. And this is very important observations of carbon dioxide. Carbon dioxide is the main greenhouse gas which causes all global warming as well as climate change. And I would like to mention about this contribution from Dr. Charles David Keeling. He's a wonderful person who started a small observatory in Mauna Loa, this in Hawaii. And he started very systematic observations of carbon dioxide, very sophisticated but very clean observations of carbon dioxide. And this is the right-hand side, which we can see that this is a beautiful observation how it increases with the time, carbon dioxide concentration. And in 1970s, I think NOAA has taken over this observatory from David Keeling, and he has really contributed. The same kind of set of observation with the standards, etc., is being followed. And you can see that the very systematic increase in the carbon dioxide concentration, and carbon dioxide is mostly it's a very gas which is distributed uniformly throughout the world. So any observation at one given point will always give a kind of a global observation. It's a mean observation. So it is crossed almost on 400 ppm now, already crossed. It is close to 420 or so now. And you can see that there are small ups and downs in the line, along the line, the red line. And there is nothing but the seasonal cycle because of the vegetation, etc. And we also have Ministry of Earth Science has set up a small observatory in Pune. It's at Singhad and hills, top of the hills. We have an observatory, and the last few years we have observation. The blue line shows the Singhad observation over Pune, and the red line shows the same kind of observation over Mauna Loa. What you can see is the trend is almost similar. The increase in carbon dioxide is observed at Mauna Loa as well as Pune are the same. but the seasonal fluctuation is much larger in Pune when compared to Mononol. And also we have to, when you talk about climate system, not only greenhouse gases, and also we have to see about atmospheric aerosols. Atmospheric aerosols are also important component, and ISRO is, thanks to ISRO, they have set up a lot of observations along the throughout the Indian subcontinent, and they have a beautiful network which has been going very well. And this the right-hand side figure, which is taken from Dr. Krishnamurthy paper, is clearly shows an increase in the atmospheric aerosol content, and this basically came from ISRO aerosol network. And ISRO aerosols are classified into primary. Basic, for example, dust aerosol is primary. It is produced in the atmosphere. And secondary aerosol is basically a chemical process. The gas is first released, then it converts into, through a chemical process, converts into aerosol. For example, sulfate aerosol is formed accordingly. It's basically from sulfur dioxide, it reacts with OH radicals, and sulfur dioxide, sulfate aerosols are formed. And aerosols normally have a cooling effect on climate, and except for the black carbon, which is a warming effect. And concentration of atmospheric aerosol loading over India is increasing. There's no doubt about it. And it has an effect on solar radiation. And there was a phenomenon was happening in the, especially in Europe. It's called solar dimming. The surface solar radiation was decreasing with the time, mainly because attributed to the atmospheric aerosols. Atmospheric aerosols can scatter, and it can stop the solar radiation reaching the surface. The top figure, which clearly shows all sky solar radiation. This is from Indian observation. In India also, we have seen this kind of phenomena called solar dimming for many years. And below, bottom figure, left-hand side bottom figure clearly shows the clear sky thing. And last few years, you can see a small increase is happening. That is because of the right-hand side is a diffuse radiation. Diffuse radiation is nothing but it is caused by aerosols. And clear sky diffuse radiation means basically aerosols. And clear all sky means it could be even from clouds. So if you really want to avoid the effect from cloud, you can see the only clear sky that could be attributed to aerosols. So aerosols are increasing over India, and that has really caused increase in diffuse radiation. But whereas total radiation is also dimming. And land use changes, we know that there are two data sets. Left-hand side is age croplands data, and right is height cropland and precious data. You can see that first one is, the top one is 1750, and second one, the bottom one is 1990. You can see there are a lot of changes happening, especially in Europe, in North America, and India, China, and some parts of Australia. There are a lot of changes are happening in the land use changes, the way that we do the agriculture. And the right-hand figure also shows the similar feature. So the land use changes. If we changes the land in terms of usages, the land surface properties will change in terms of land surface albedo or soil moisture, and etc. It will also have an interactive mechanism, interactive feedback to the climate system. So now question is how we predict future climate, and it's a similar way we predict weather. Whether we predict for next 3 days, 4 days, 5 days, climate in very larger time scales, years to 50 years, 60 years. But the basic principles are same. Almost like weather prediction. So we use the same equations of weather prediction models. Basically, equation of conservation of momentum, conservation of mass, and thermodynamics, etc. And we solve it because it's a nonlinear equation. We solve it using some empirical method, either spectral methods or partial difference methods, and you use very large supercomputers to solve these equations and predict. For weather prediction, we use very high resolution model. Climate change, for predicting future climate, we don't use that kind of high resolution. For example, weather prediction, we use even 2 kilometer, 3 kilometer resolution models, whereas in climate, we use 50 kilometer, 100 kilometer models. And because question is computing time, we can theoretically do it for 10 kilometers also, but the computation time is very much wanted. So then how we predict? So in the weather prediction, in the initial condition, you run it for 3-4 days, or even up to 1 day, or 1 week, 10 days, etc. Whereas in the climate, future climate, what we do is we don't say it's a prediction, we say it's a projection. So there's a lot of uncertainty involved in future climate. So we say it's not a prediction. Whereas weather we say prediction, whereas in climate we say it's a projection. And we use advanced coupled climate system, or S system model we call, in making projections. So S system model is similar to weather prediction model, but it has much more different physics components in the S system model. Very interactive systems are there involved in that. And in future we don't know how the greenhouse emissions will We know what happened so far, but we don't know what will happen in the future greenhouse emission in the future. So that will depend upon how the particular country, for the all the world, how they are going to burn, how fossil fuels, how they are going to alternate energy sources like, for example, green energy, and how much population is going to increase, how much is the economy is going to increase. It's all social factors will finally decide how much greenhouse gas is going to be emitted. And so the IPCC reports, we normally assume some kind of a representative concentration pathways we call RCP, and a different RCP scenario we can go 2.6, 4.5, 6.0, and 8.5. These numbers are basically the top of the atmosphere radiative perturbation in terms of watts per meter square. So 4.5 means 4.5 watts per meter square changes can occur, and the perturbation due to changes in greenhouse gases, the top of the atmosphere, by 2100. That is the meaning. And in all the scenario, 8.5 is very, very extreme scenario, which we should really rule out. That may not happen. 2.6 is too ambitious, and that means all countries will immediately stop the burning of fossil fuels, which will never happen. 4.5 is the exactly what we are now going to do. And so 4.5 scenario is a reasonable scenario in which we can really understand how the future climate changes will happen. And the models basically treat all the essential components of their system. The present day models have improved substantially in fidelity as well as resolution. And so it's very important thing. The climate models are improving. And however, model producers still have inherent uncertainties, especially when you talk about regional climate change projections. So as I told that the Earth system models, the so-called Earth system models, are basically treat all these components which we the physical process which I mentioned earlier, all these components, interactive systems, interactive feedbacks, etc., will be treated explicitly or in terms of parameterization in the climate system. And while talking about climate change, I would like to mention about these two gentlemen who got the Nobel Prize last year, which is really a big boost to the all climate science community, because people used to think that what this climate science people are talking is nonsense, and it's all not reasonable. So Nobel Prize Committee has really given kind of an appreciation of what the work is done on climate change. The first is the Manabe, who really started climate modeling work. He usually started in 1969 paper. Is basically it's a one-dimensional radiative convective model, and in the atmosphere above 1.5 kilometers, so it's a basically radiative equilibrium. Whereas in the lower atmosphere, it's a radiation plus convection. Both are required to get the equilibrium. So one-dimensional convective equilibrium radiative convective model the UK used. And he predicted that if you double the carbon dioxide, it will increase the radiative forcing about 4 watts per meter square, and temperature change with about 2.5 to 3 degrees Celsius or so. But even now, the sophisticated climate models, when we use the projections, what we get is almost similar. The quantitatively, the results are almost similar. What he got in 1969. So then he moved into the 3-dimensional models, etc. Whereas in the right-hand side, the Hasselmann, who is basically working in Germany, he tried to prove that whatever the climate change is happening mainly is attributed to the anthropogenic forcing because of the human activity. It's a very, very important finding. He has found that the climate change is not what we are seeing is not due to natural variability. Of course, natural variability plays a role, but in addition to that, this important component from anthropogenic forcing. So both these contributions, these two gentlemen got the Nobel Prize last year, and we are very happy with that. And in IITM, Indian Institute of Tropical Meteorology, where I have worked briefly, and it's an autonomous institution under the Ministry of Sciences. It's a beautiful institute, and they have a center called Center for Climate Change Research, and Dr. Krishna is heading the institute. And they have developed the S system model. That's the first time we developed a S system model. And a system model is little more advanced than the climate model, and which makes use of some biogeochemistry. It makes use of and uses the aerosol interactive process, etc. And they developed now the second version model is available, and the model is the fidelity of the model we have checked. Of course, there are some errors still, like any other model, but this model is too good to make use of for climate change projections. So in the earlier IPCC reports, when the reports were coming out, then there was always a criticism from Indian community saying that all these models are made in USA or UK. They try to tune the model to get the results in their own, and there is no Indian representation. So that was the turning point for us to develop our own model. And this model really participated in the 6th Climate Change Assessment Report, IPCC 6, which was brought out very recently, very few months back. And first time that Indian Earth system model participated in the climate change IPCC report. Is a very big achievement from our Indian side, Indian climate scientists from our side. And the model is too good. And of course, there's a need for further improvement, and especially in terms of resolution, because we are not able to run the model in high resolution because of the computing restrictions. And I will not go into detail of the model. This shows that model is too good. And also, when I was secretary to Ministry of Earth Sciences, I was very particular to bring out this assessment of climate change over the Indian region. A very authoritative assessment report from the ministry, from the mouth of the Ministry of Earth Sciences should come out to tell the people that this is happening. And otherwise, we used to have so many research papers here and there, but kind of a consolidated report from government organizations should come out. It was my intention, and Dr. Krishnan's group at the Climate Change Research, they have assembled together. They did a wonderful job, and this book was published very recently by Springer. And I ensure this book should be open access book. We don't want people to spend money to buy this book, so it's freely available. Of course, we spend money from ministry to publish this book as an open access book, but this book is available free of cost. Anybody can download it and read it. And you can see that how many, just 1 year back, it came out and 210,000 downloads now, freely downloads, and 101 citations. Really impressive assessment change report, which we have brought out. And I would like to give this remaining slides, basically the results, what we are seeing from Indian perspective, from this, basically taken from this report. And anybody, if you want anybody to download this report, please download it. It's a beautiful book. And when you talk about climate effects of climate change, it not only the change in the mean pattern, it's also change in the extremes. If you assume that it's a Gaussian distribution, so any change in the mean, not only change the mean, it also changes in the extreme. The right hand side, the extremes will also change. The same way, it's increased variability. Mean is not changed, but variability is changed. Ultimate thing is the variability, the extremes also changing. So a change in the mean as well as variance can change the extremes. So that is very important. So when we talk about climate change, not the mean is changing, it's also extremes are changing. And this can be changed. This can be resulted mainly because it's not only the mean is changing, it's also the variability also can change in the future climate. And I will start with the global surface air temperature trends, which we have seen from last about 115 years of data. You can see that every year is warming. The whole world is warming, except a few places where gray is in, where the data is not available. But if our data is available, the whole globe is warming. Of course, warming is not uniform. Some places warm more, some places warm less, but warming is happening everywhere. And if you really take all the observations and make a time series area weighted average and just plot a time series from 1850 or so, we have data from, it's all surface instrumental observations. So not proceed actual observations taken from thermometers. And these observations are from 1850s, and which very clearly shows that after 70s, you can see the sharp increase in the temperatures is happening. And if you really plot the carbon dioxide concentration also, it will go very, very hand to hand. And very beautifully it will go. So mainly the last 50 years or 60 years of data very clearly shows this unprecedented warming is happening. In last 10 years, if you see, the last decade was the warmest decade ever happened during last 150, 170 years of data which we have. This is a global mean. And even if you plot the annual cycle every year from blue to red, you can see blues are 1880s. And the red is last on the top one is 2019. You can see how much the warming is not happening only a few months. It is happening uniformly throughout the annual cycle. And you can see the whole increase in the annual cycle every year. And now it's the annual cycle. You can see the top of 2019. You can see the top of this curve. And because of the warming, sea level rise is happening because of the thermal expansion. One reason could be thermal expansion of seawater. And another is also not only the sea surface temperature is changing, but the ocean heat content, how much heat is produced in the first 100 meter of the depth ocean water, and that also is increasing. Ocean acidification is happening because carbon dioxide what we are emitting is almost 50% carbon dioxide is absorbed by oceans. Ocean is a sink of carbon dioxide. So once oceans absorb more and more carbon dioxide, its acidity changes. It will become more acidic now. So ocean acidification is happening. That can really change the ecosystem, the marine ecosystem in the oceans. And this is a beautiful figure which Dr. Hazelman really produced. I would like to emphasize this curve. And the black line clearly shows observation, which you can see the 1970 onwards. There is a sharp increase in the temperature there. And so you run a model and using all these prescribed data, for example, variability and anthropogenic forcing, etc. And when you don't use the changes in the carbon dioxide, greenhouse gases, etc., only do volcanic eruption and solar cycle, etc., you will get this green curve, which is bottom. You can see the last few years that green curve doesn't really fit into the observation, doesn't explain what we are seeing from the observations. But if you put in the same model, you put additional parameters like how much carbon dioxide is changing, how much methane is changing, how much nitrous oxide is changing as per the observation we have, then it reproduces the actual observation of temperature. The model reproduces very, very well. So that very clearly shows that basically what we are seeing, the global warming and climate change, associated temperature changes are really contributed by anthropogenic forces. This 19 IPCC report, fourth or fifth report, they very clearly wrote it. It became big controversial statement, but they are very much confident to make that statement. They are saying that whatever warming we are seeing is mainly contributed by global human activity, not by natural forcing. Natural forcing cannot explain the unprecedented warming which we have seen in the last 40-50 years. For this only he got the Nobel Prize, and of course many other work he has done. And global, of course, this I will skip. And so this is the future changes in temperature from the climate models. What we are saying, IPCC report, latest report, I have reproduced it. And left-hand side is the 1.5 degree warming. If the whole world is, if you average it, you will get 1.5, and 2 is in the middle, and 4 is the right one. Of course, we should not even look at this 4 degree warming figure. And so now you can see from newspapers and discussion TVs, etc., the government is trying to minimize this, restrict the warming up to 1.5. That's what all people, UN is telling all the countries to try to restrict to 1.5 degree warming, which we personally feel it did not happen. So, but then at least 2. You should not go beyond 2. 2 itself will be very grave situation, but we want to restrict it to. And even 2, you can see that the whole world is warming. And warming is much more in Arctic as well as in Antarctic. So the polar region is warming much more than any other region. And we call it is Arctic amplification, mainly because of the feedback process from the ocean as well as the cryosphere, etc. The Arctic region warms up much more than any other region, and we call it Arctic amplification. So this is the pictorial representation what we can expect in the coming years. And I'll now, because basically I'm supposed to talk about Indian scenario, I will talk about temperature changes over India. This is observations. We have about the 350 stations of maintained by IMD. If you analyze all the observations and try to reproduce what we have seen from 1901 onwards, reliable data, very reliable data. And up to 2010 or so, 2010 or so, what we are seeing is the temperature is changing everywhere, and except the small portion in the north parts of Gujarat, some parts of Bihar, etc., temperature is decreasing. But otherwise, the whole country is warming. And even if you plot the annual time series, temperature anomaly time series, if you really plot, you can see the substantial increase last few years. You can see the last 15, 20 years, always the anomaly was positive. And that means the warming is happening. And warming trend is almost very similar to the global warming trend, and about 0.6 degree or so in the last 100 years. So the Indian region also warming as any other region. And this is the future projection. This I taken from Climate Change Assessment Report of 2020, which IITM has produced. So this is how scenarios will change. And the left-hand side very clearly shows there are three different scenarios. So I said 2.6, 4.5, etc. Left-hand side is 2.6, middle one is 4.5, right-hand side is 8.5. I request that you don't look at right-hand side because it is too deadly scenario and it is not going to happen. It's basically academic industry people are running it. But middle one is more appropriate, and you should see the changes happening in the middle portion, 4.5 scenario. And you can see the surface temperature are expected to increase everywhere in the country and more especially over northern parts of the country. And I will give a time series also next slide. And so this is the time series which we can expect a future climate change from our IATM model. And again, RCP 2.6, 4.5 and 8.5. Blue line is RCP 4.5. A temperature increase about 2 degrees or so is expected by 2100 for Indian region. 8.5 of course is almost 5 degrees, and 2.6 is a very ambitious scenario which will never happen. And so we can expect a 2 degree warming over the Indian region by 2100. And what black line in the initial data clearly shows the observations, which the model also reproduces very well. And remaining from 2015 or 15 onwards also is a lot of future projections. And when we talk about mean temperature, now question is what is the extreme temperatures? How the extreme temperatures can change? The top one is cold nights and days, and the bottom one is warm nights and days. So what we are seeing in different scenario, cold nights and days are going to decrease. And of course, not this year. This year is very abnormal year, 2021, 22, especially for people like living in Delhi, things are pretty bad. But in general, cold nights and days are going to decrease everywhere in India, and warm nights and warm days are going to increase. So that's very typical of global warming scenario. And right-hand side is also same way. It's left-hand side is cold night and right-hand side is cold days. Similarly, warm nights and warm days. So both are increasing. So, and also the heat waves. Heat waves are probably you must have heard about heat waves, and especially people staying in northern parts of India, as well as the coastal area or Andhra Pradesh, Orissa also experience heat wave. People in the south, of course, especially some parts of Kerala also experience the heat wave. And this is a 2003 European heat wave. It's a very famous heat wave. 40,000 people died. 40,000 people died in one heat wave. It lasted about 10-15 days. And it was unprecedented heat wave. And many papers are written after the heat wave. And people are very clear. People have clearly made a statement saying that this 2003 European heat waves mainly contributed to by human activity. It is called, in the climate models, we can do the attribution. Why this change is happening, why this event has happened. Normally when an event happens, we normally attribute saying that, oh, it could be climate change. But that qualitative statements always we can make, but then you have to prove it. So that's a science we call attribution, climate change attribution. So after people like Heiselman has done a lot of work on attribution. And so it's a very detailed statistical analysis. We should do it with the climate change model. And European heat wave, they made attribution studies and very clearly proved that European heat wave was mainly attributed because of the climate change caused by human activity. And in India also heat waves is increasing. The left-hand side shows the mean pattern. The top one is the frequency. Right-hand side, the top one, top one clearly shows the duration of heat wave. Bottom one is the maximum duration, how many days it will persist. And this is the mean pattern. You can see that most of northern India is affected by heat waves. Right-hand side, very same thing, but in terms of trends. You can see the frequency is increasing, duration is increasing, maximum duration also is increasing. So everything is changing. So heat waves are increasing over India. These are observational data, well proved. And how the future heat waves are increasing. Left-hand side is taken from a paper by Rohini et al. She used different climate models, and the left-hand side basically shows how many duration days, how many days in a season, in the pre-monsoon season, you can expect the heat waves, and that is going to increase. There's no doubt it's increasing. It's about 20-25 days. By 2060 or so, we can expect 20-25 days of heat wave days during the pre-monsoon season. It's a big number. It's a big number. It's almost now 10 to 12 now. Going to increase to the right-hand side. Again, I taken from the climate change assessment report. Also clearly shows the top one is the frequency, right one is the bottom one is the duration days, how many days. And both shows the heat wave days as well as heat wave frequency are increasing in time in future. So we should expect a much more increase, much more trouble from heat waves in the coming days. Indian Ocean warming is well known, and this is also taken from the same report by a chapter written by Roxy. And this also very clearly shows Indian Ocean, among all the ocean basins, Indian Ocean is warming much better, much faster than any other ocean basins. And Indian Ocean warming can be caused for many aspects. For example, the increase in the precipitation, extreme precipitation, heavy rainfall over India is caused by Indian Ocean warming. It is one of the contributors is Indian Ocean warming. There are a lot of papers that were written by Professor Grossi has written. We have written a lot of papers. Very clearly shows the link between extreme precipitation over India as well as Indian Ocean warming. And the climate model, future climate model, very clearly shows that warming is going to not only persist, it also will oscillate much more in the coming years. So Indian Ocean is going to warm up much faster in the coming years, which can lead to many different kind of consequences in terms of extreme precipitation over Indian region, etc. And as far as rainfall is concerned, we know that monsoon rainfall is basically our bread and butter, and we have 4 months of monsoon rainfall for whole country. And for South India, we have another monsoon season, northeast monsoon for a few months. And if you really plot the all India rainfall time series, that means take all the data, average it and plot it, you get a robust monsoon. So monsoon, we are lucky, the monsoon is very robust, it's very stable. And you have a large multi-decadal oscillation variability, is about 30-year cycle. And the large internal variability. So it has a large internal as well as interdecadal variability, monsoon X. But long-term trend, if you take an all India rainfall, there is nothing. So monsoon is very robust. But if you go in a region-wise, there are changes. For example, this figure, left-hand side figure, again taken from the report, very clearly, so the red lines are, red dots are all where the rainfall is decreasing. So, and for some Kerala, rainfall is decreasing. Eastern part of central India, rainfall is decreasing. But there are places where rainfall is increasing. For some Gujarat, some parts of Maharashtra, interior parts of Karnataka, Rajasthan, Jammu Kashmir. So these are the places where rainfall is increasing. These are all observations. Right-hand side is October, November, December is northeast monsoon, which clearly shows over Tamil Nadu region you get more and more rainfall now. And this year, last year, 2021, northeast monsoon was very typical monsoon season, which we got a lot of rainfall over Tamil Nadu and neighborhood. So these are observations. So there are changes in the regional pattern, but if you take an all India rainfall figure, it shows very stable. Monsoon is robust. But if you really see the future projections, left-hand side, you can see it's RCP 4.5 scenario, annual rainfall, JJS monsoon season, summer monsoon and winter monsoon. You can see that different kinds of models they use. And it all very clearly shows there's a small increase in the monsoon rainfall. So this is a systematic increase in the monsoon rainfall is going to happen in the future. So monsoon rainfall as it is, the total rainfall is going to remain same or it is going to increase little more. That's a good signal which we are getting, good reason which we should be happy. But this is the different spatial pattern, the same thing, and RCP 4.5 near future. RCP 8.5, you please don't see it. RCP 4.5, top one is annual. Middle one is JJS and bottom one is OND, October, November, December. You can see that October, November, this very interesting things are happening. Some models are very clearly shows that western parts of India is going to get a lot of rainfall in the near future. Whereas in the monsoon season, mostly South India is going to get, and even northern parts of India is going to get. But if you take an all India average, you get a small increase in the monsoon season rainfall in the RCP 4.5 scenario. So that we should be happy with that. And that is mainly because of the large increase in the vertically integrated moisture transport and also moisture convergence. If you have more temperature, more moisture, more evaporation, you get more moisture convergence is happening over the Indian region. Winds are becoming very stronger. So you get more convergence, so it can cause to more moisture transport as well as moisture convergence, which can cause to more rainfall, mean rainfall. But however, there are changes in the pattern. For example, drought. In some years we get drought, and even in a normal monsoon year, some regions can experience droughts. And this is a trends in droughts. So and droughts can be monitored using different indices. One is, for example, SPI, this one is SPEI. So these are based on SPEI, which very clearly shows the drought, the duration of the probability of the reporting area. Area affected by droughts is increasing. If you take the total area of the country, the area is increasing. That means more and more region is going to get droughts in they are getting in the past. And that is going to happen in the future. This is the climate change projection in the future. We can see that the change, percentage, left-hand side shows the percentage change in frequency per decade of moderate and severe droughts. It clearly shows an increase. Right-hand side shows the percentage area affected by droughts. Both are showing an increase in the drought frequency as well as the area in the coming years. So as I said in the beginning, that the climate change doesn't mean only the change in the mean, but it can also change in the variability. That means drought can increase as well as flood also can increase. And this is the heavy rainfall events. When you take a country like India, you get a lot of rainfall in over central India, which is more than 15 centimeters in a day. And this is the frequency, the mean pattern. And if you take a long time series and plot it, you get a large multi-decadal variation is there. But in addition to that, last 50 years, if you take large increase in the frequency of heavy rainfall events happening. This is well recorded. It's beyond doubts. Frequency of heavy rainfall events over India is increasing, especially 15 centimeter, 10 centimeter, etc. So we tend to get more and more rainfall. Even though total rainfall may remain same, but we tend to get more and more rainfall. And rainstorm, of course, this data are basically grid point data. But even if you assume the rainstorm is a spatially homogeneous region. For example, associated with the monsoon depression, etc. So that also the rainstorm days is increasing, rainstorm events also is increasing. So both have shown an increase in the rainstorm days as well as events. And in future, what will happen means the rainfall extremes. If you take, for example, 95% rainfall, the top left-hand side is 95% total rainfall is also increasing in future with different scenario. And simple rainfall, daily rainfall intensity index also will shows, and 5-day even rainfall, 5 day, take every 5 days and totally, and how that is going to change in the future. And because 5-day precipitation events is important because that can really lead to large scale floods. 1 day just rainfall may not really lead to, for some river-based floods. A 5-day event can really cause a river flood. And so that also is going to increase. So the extreme precipitation is going to increase in the future over the Indian region. And same thing shown here, maximum 5-day precipitation, left-hand side, near future and far future. Near future means 41 to 70 and far future means 71 to 2100. And also very important, right-hand side is consecutive dry days. You can see that in any particular day, particular place, you don't get all 122 days of June to September. You don't get everyday rain. You get some days rain, then dry spell, then again rain. So what is going to happen means now dry spell days is going to increase. Consecutive dry days is going to increase. So that means one rain has happened, then after days, many days of dry spell, then only you can expect another rainfall spell, which is really bad for agriculture. All agriculture people should really tune their agriculture practices as per these changes occurring in the rainfall. The mean rainfall will remain same. So what is happening is the frequency of heavy rainfall events is increasing and consecutive dry days is increasing. That means number of rainy days is increasing, and when it rains very heavily. So there's a lot of changes in the precipitation characteristics in the Indian region, the monsoon, especially in the monsoon season. So that is going to harm us like anything. And we need to really prepare. So that can, for example, intense precipitation can lead to flash floods, large scale river floods. It can really cause damages to the agriculture. Similarly, large spell in dry days also can cause a lot of damages to the agriculture. So these are all important. Then sea level, of course, sea level. India is now MOS is putting up a lot of observatories along the coast is called tide gauges. And earlier we had only few tide gauges. For example, top one historical tide gauge data which shows that Bombay, Kochi, where our sea level is increasing. Now we have put a digital kind of tide gauges along the Indian coast and also on outside. And so we can really monitor what is sea level is increasing, which clearly shows that future change in sea level is going to increase it. And global means of evolution derived from tide gauges and altimeter data. And the right-hand side is the future projections. Everywhere, the whole world, whole ocean basin, sea level is going to increase. Of course, it may not be uniform everywhere. And so this is also taken from climate change assessment report. And I'll almost reach in the end. Now the question is Himalaya. Himalaya is a very important region for India. Himalayan is very important. So Himalayan ecosystem is very important, vital for India. It helps the Indian monsoon to get established, and many small states are there along the many lakhs of people, crores of people are staying in Himalayan region, where they are very much important for the Himalayan ecosystem, very much important in terms of agriculture, water, etc. And so the ecosystem of climate change, Himalayan region also is changing. And it's an important contribution made by, again, IITM scientists. They found that the temperature, you can see this temperature changes happening in the Himalayan region versus Indian region. And the yellow is Indian region. And the background, you can see the gray color, gray bars, which are all Himalayan region. And the Himalayan region is warming much more than Indian region, basically the average of Indian rainfall, Indian subcontinent. The Himalayan region is also the higher topography. So at higher, if you go up, normally the temperature increase, the trends are normally much more than the plains. So Himalayan region is warming much faster than the Indian plain region, which is very important. And also in terms of precipitation, and you can see that especially in the Jammu Kashmir area and adjoining Pakistan area, the rainfall is increasing. And this increase in rain precipitation, annual mean precipitation over that region. And if you really see in the future projections over this region, surface temperatures are increasing and precipitation also small increase is happening, but snow is decreasing. So any change in the precipitation characteristics can really change the water balance over the region. So there the snow and ice formation is very important for the Himalayan region, because in the spring the ice can melt and it can contribute to river flow. And that is very important for further pre-monsoon season over the downstream of the rivers over from Himalaya. And so if enough snow is not happening, enough melting is not happening, that can lead to changes in the water balance over the region. So these are all very critical. So a lot of things are happening in the Himalayan region which are not really good for that region. And glaciers are melting, so I will not go in detail. So very clearly, this is a paper by Kulkarni, and he's working in IISc Bangalore. He's established scientist working on glaciers, and he has done an extensive work which clearly shows us some of the Himalayan glaciers are melting. And MOES has set up a station in Himalayas. It's about 4.5 kilometers. I remember going there in a helicopter for inaugurating this station. It's very far. And it's in Himachal Pradesh. It's called Himanch. And our people go in summer, because winter it's very almost inaccessible. And summer we go there, we take observation how the glacier dynamics is working. And summary: surface air temperature is likely to further increase by 2 degrees by 2100. This is all I'm talking about Indian region. Extreme temperature and heat waves frequencies for the duration are likely to further increase. Monsoon rainfall would be very robust, but a small increase in precipitation is expected. But extreme precipitation events likely to increase. Spells of dry days are also likely to increase. So area affected by droughts likely to increase. Sea level is likely to increase along the coast, so that can lead to sea erosion to further increase. Already 30% of Indian coast are damaged by sea erosion. So this number may go up. And Himalayan region is likely to warm more, glaciers to melt, and would affect the regional water balance. Now I have only 2-3 slides, very important slides. Now we know what changes so far we are seeing in terms of observations, and we also know from the climate model what is going to be expected in the future. However, there are uncertainties. We should not believe completely all these things which we are going to what we are seeing from the model. There could be uncertainties, and which we need to really document properly. Uncertainty is very important, and especially policymakers will ask you a question: how confident you are about these projections? So we scientists, we should tell that this is the confidence level, which we can easily do it. And so with this uncertainty determination is very important. And once we know this much, now the next question is, so what? So rainfall is going to change, temperature is going to change, heat wave is going to increase, so what? So question is, what could be the impact of this climate change in the future on different sectors? For example, what could be on health? whether we can expect vector-borne diseases to increase. Agriculture. I told that there are many reasons for worry for agriculture because of the changes in the characteristics of precipitation temperature. So we need a climate resilient agriculture. Water, there could be a lot of water stress, especially drinking water, energy, and with future warming, we need more and more energy demands will be there. Disaster is going to increase. So all these things we need to really understand more. Now we have plenty of data available. This is high time that research community come up with proposals and sit and do the impacts. Impacts are very important. Then they also come out with adaptation strategy. What the government should do, and this will be a good lesson for the government to learn from what we are going to experience. We need not worry about 2100, but we should know about 2030, 2050, up to 2050, what we can expect. The government can really make the policies accordingly. And I will not go in detail about the impacts because it's again gray area, but I will talk about this slide. I normally do it with all the climate change presentation. This is done by WHO. The top one clearly is global, all countries, but blown up or screwed down depending upon the cumulative emissions of greenhouse gases. For example, Northern America is blown up because they contribute more. Europe, they blown up because they contribute much more. But when you talk about health impact, you see down. Poor countries like Africa and Asia is blown up. But the impact will be not on America or Europe, but the impact will be on poor countries. But the contributors to global emissions are from Europe and America. So impacts are for different countries. This is very, very important. There's a lot of inequality in terms of climate change effect. Somebody is emitting, but the effect is more seen in some poor countries where their contribution to global warming is much less. Climate tipping points have been pointed out. That's been point of no return. Point of no returns have been already identified. It's a very famous paper in Nature in 2019. They identified about 8 or 9 tipping points. Of course, unfortunately, there's no tipping point over India, but nearby we have coral reefs, and mostly it's in the Atlantic Ocean, and for example, Antarctica as well as Arctic, Amazon rainforest. There's a lot of tipping points where we should not expect any return points. It's all gone that side. This is the last, probably the last slide. Is the top 10 risks made by World Economic Forum for next 10 years. If you really see with the return, what is the return? They're not arguing about anything of economic issues. There, the top 10 risks is extreme weather, climate action failure, natural disaster, biodiversity loss, and human-made environment disasters. So these are the top 5 major risks we are going to face in next 10 years. The message is very clear. It is not made by climate scientists. It is made by World Economic Forum. They are very clearly saying that the environment as well as climate change is going to happen. We will be the major risk for next 10 years for the whole world. So let us make commitments to save our beautiful blue planet. May not be for us, but for our children and our grandchildren. With this, I'll stop here. Thank you very much once again to ISRO as well as IISER Kolkata for giving me this opportunity. Thank you very much.
Thank you, Dr. Rajeevan, for your lucid presentation in your own impeccable style. And your presentation has really covered almost all the aspects of the climate change, including the Indian scenario, starting from the Earth's radiative balance, various parameters, the GCOS. We also talked about the regional climate projections and also the weather predictions, and particularly the RCP 4.5 scenario. But also on your own efforts with respect to the assessment of climate change over Indian region, and also to make this publication and the book available for the open access, which will really go a long way. We also very detailedly covered the Indian scenario, particularly apart from the global scenario, and really some of the alarming scenes like 2.2, almost 2 degrees centigrade increase in temperature by 2100, and also the increase in the rainstorm. And the main cause of concern, which you have very nicely covered, is about the Himalayan ecosystem, which is already very fragile, and the way it is getting warmer, and also the aspects of the alpine forest, the glacier, the cryosphere, which needs to be studied and particularly somehow conserved and protected to really serve for the climate change efforts. So thank you very much, sir. First, I would like to take some of the questions which have already been put on the chat box, which I can read directly. Maybe a couple of questions I will take from that. Questions are many, so I will just take the liberty of selecting the few of them and ask then maybe one or two questions from me as a chair, and then I will also keep the forum open for some time to ask some of the questions. One question is, of course, the person has thanked you for your excellent presentation on the global climate change. And he's talking that, is there any impact of solar variability as a natural forcing on increasing trend of the surface temperature? And if it is, how to distinguish the natural anthropogenic forcing of this particular increasing trend in the global as well as the Indian surface temperature?
Yeah, solar cycle has a role because 11-year solar cycle can have an impact on temperatures, but it may not have an impact on the large term increase in the temperature. It cannot cause a large scale increase in trend in the temperature, especially in the global scale. So, but 11-year there could be a modulation in the temperature time series. And we can differentiate in terms of some statistical methods. We can differentiate the effect from cycle like 11-year solar cycle. There are methods, statistical methods, especially time series trend analysis, where when we do it, we can do this. You can use the 11-year time series, and you can separate it out, remove it, and see the residual time series and analyze for. We can do that.
Thank you, sir. The other question is from Mahinder Rajwar. He wants to ask, does the climate change has any relation with the extreme weather events? Particularly, he's asking with respect to the cloudbursts or the heavy rainfall.
Yeah, climate change is climate change can cause extreme weather events. That's the message of my talk. It can really give more extreme weather events, and so cloudburst also cloudburst, for example, 10 centimeter more in a particular 1 hour or so is not defined as a cloudburst. That also can increase because of the global warming, especially in the Toba area where hilly regions are there. This kind of events can increase. So these are all. So every event may not be caused by climate change, but in general, we can attribute this increase in, we can expect the increase in the extreme precipitation as well as cloudburst in terms of global warming.
Okay. So another question is basically, why are the intensity of lightning and the thunderstorms in India and also the severity of cyclonic storm in Bay Bengal increasing in the recent years?
Yeah, there's again caused by global warming, because when temperature is increasing, the convective activity, convective instability we call, and we have different formulas to calculate convective instability. They're all related to temperature as well as moisture. So the instability in the lower atmosphere will increase more, and we'll have more unstable atmosphere, so which can cause to more thunderstorms, and more large scale development of CP clouds, and can give rise to more lightning. So that is going to happen. That very easily can be attributed to global warming and temperature increase as well as moisture increase. Both should happen.
I'll also take a few of the questions from the YouTube chat, because large number of audience are also listening your talk from the YouTube. So one is the question is, why the predicted surface temperature based on the natural forcings are smaller after 1970s than before?
Well, I don't have a ready-made answer immediately. I'm not sure what he really means. Okay. And of course, the contribution by in the warming, if you really see the warming of whole time series, the warming contributed by anthropogenic effects is much more. The forcing is much more than the natural variability.
Okay. And sir, why is the Indian Ocean warming much more than the other oceans? And what is the role of Indian Ocean dipole, which is a natural oscillation similar to El Nino or La Nina in the rainfall over India?
Well, my question is why Indian Ocean is warming. There are many theories are coming out. There are many papers coming out, which I cannot explain now in detail. And there are reasons for warming up, more warming over Indian Ocean. And Indian Ocean dipole has a role to play in Indian monsoon variability. And for example, positive dipole normally contributes to more rainfall, and negative dipole normally contributes less rainfall, and so. So, and climate change also can affect the characteristics of dipole. That also we have to remember.
Okay. And sir, you have also covered about the particularly the temperature trend, and also you have the going to have the more warmer nights and day also increasing. So related to that, one person has asked that it is said that due to increase in greenhouse gases, our summers are becoming hotter. But what makes our winters colder? Yeah.
So the whole thing is shifting to right hand side of the spectrum. So see, we get more and more warmer days, but lesser and less colder nights. So that is the reason. So because of warming, the whole mean pattern is changing to right.
Okay.
That is happening everywhere, most of the places.
Okay, sir, I just would like to ask you, sir, since you talked about the regional climate projection and also the global climate projection, not the prediction. So, sir, how is our capability, particularly, Indian capability, I would like to ask, in terms of accuracy, whether we are able to really give accurate regional climate projections, or we are also equally equipped to give the global climate projections?
So, see, the models which are IITMA has developed, the CCCR Earth System model, is a global model. But they also, from the global model, we can derive regional pattern. And also, in addition, they have also another experiment called Codex. They run another very high resolution regional model to, and the boundary conditions, etc. They take it from this global model, and they can make a separate projection for the region separately. The Codex experiments also they completed, the Codex is also available. And so we have capability of not only making global projection as well as regional projections. But I will tell you, when you go for regional projection, the uncertainty could be more.
Okay.
Large scale global patterns can be, for example, what is the globally average temperature? We can have much more certainty. But if you go for what will happen to Tamil Nadu in next 50 years?
Okay.
Well, we can theoretically say, but then there could be errors.
Sure. And sir, one more is, sir, now we generally talk about, ocean. Of course, you have given a very detailed and enlightening coverage during your talk. But if we talk about the marine ecosystem, sir, what are the capabilities we need to still build to really effectively contribute to the global community, particularly with respect to the marine ecosystem? In terms of
marine ecosystem is very important. We have capability in Indian MOS institutions like INCOIS. There is one Center for Coastal Research. Then one CMLR in Kochi. These are institutions where they work on marine ecosystem. Some group in NCPR also. But we need more and more people to get involved in marine ecosystem and to understand what is really happening in the not only the surface but in the marine, for some marine biological system and marine biodiversity. Biodiversity is very, very important. Marine biodiversity. And because of the changes in the climate system, marine diversity can have a really impact. And you may be remembering the launch of Deep Ocean mission by Ministry of Sciences recently. And there is a component on marine biodiversity in that. So there will be people will be working on try to understand how the marine diversity is going to change. But MOS, I'll tell you frankly, MOS alone cannot do this job.
Yes,
so you need involvement like institution like ISRO. You need a lot of participation from academic institutions, universities, and all. It's a huge, many number of people are required, and the huge effort is required.
Sir, one more question has come now on the chat is does the recent Tonga volcanic eruption have influence on the global CO2 levels or on the Indian ocean warming? Of course, this is a specific case person is asking.
Yeah, normally see, for example, Pinatubo eruption in 1991, I think, so that had an effect on global temperature. It can affect even the formation of the development of El Nino system in the Pacific. Volcanoes and El Ninos are related. So it may have an effect, definitely. Definitely it has an effect, but it may be temporary. It may be maybe 1 year, 1.5 years, 2 years maximum. With Pinatubo, it existed for 2 years or so. The effect. But it may not be contributing to a permanent change in the system.
Okay. So I'll just keep the forum open for some more live questions. If any of the audience who have joined live now would like to ask questions, maybe they can raise their hand or they can ask the question. Any question? Okay, sir. Then finally, sir, to just conclude, already, of course, you spoke, but just as a thing again, as you told, of course, any one organization is not, enough or can really effectively contribute. So, just I would like to ask you, sir, as your vision experience as a secretary almost for 5.5 years, and of course, contribution as a climate scientist. So, what should be really done to build the synergy and cohesive sort of scientific environment across various departments so as to collectively contribute to the cause of addressing global climate change?
Yeah, now unfortunately there's not much synergy is happening. I should admit. But if I was secretary, I would not have told this statement. But now I have come out again. I am brave enough to say not much synergy, but it should happen. Frankly speaking, it should happen. DST is doing their own program on climate change. ISRO you have your own observational program. And everybody should come together. And I'll repeat again. MOS alone cannot do this job. And we need involvement of not only the scientific institutions as department ministries, but also academic institutions. Many academic institutions should really get involved. And funding also, see, the academic institution will get involved only unless you give some funding. So funding mechanism also should improve. And once Dr. Somanath became secretary, I written to a small email to him and requested him that you please keep a good relationship which we had between ISRO and MOA should continue, and he has assured me that that will continue in future. So that's a good sign. I think ISRO and MOA should work together much more. There's a lot of large scope. I think it should help MOAs to develop their own observational platforms, and even in science, ISRO should contribute.
Thank you very much, sir. So with this, I hand over to Dr. Dibyendu Nandi for further proceedings. You are there.
Yeah, I think Yoshita is going to take over the proceedings now. Yoshita?
Yes. Thank you, Shri Madhavan Rajeevan and Shri Shantanu Bhatawdekar. I now request the Chairperson, Local Organizing Committee, Shri Dibyendu Nandi, to introduce the participants to the conference logistics in place. Professor Nandi, the stage is yours.
Thank you very much, Yoshita. So before that, I would really like to acknowledge this wonderful lecture by Shri Madhavan Rajeevan. I really enjoyed this. I think I also do modeling, but in a different perspective. I thank you very much for accepting the invitation of the organizers and giving this talk. And we had some such nice questions from YouTube, from the chat box here. So all the different components of the online delivery system are working well. So I'm happy to find these nice questions coming in. Thank you very much. Thank you. I would like to now introduce the participants to the people who you will not see at this conference, but who are the most important for this conference, both to me as well as to all of you. They're the local logistics team who are handling our control room, and subsequently I will talk about certain important issues regarding accessibility to the online program, which is particularly relevant for all speakers and session moderators. So please hang on. I'm not going to take much time. Hopefully we should be done certainly by 1 p.m. Okay, so this, I hope you can see my screen. So this is our control room at the Center of Excellence in Space Sciences India at ISRO Kolkata, from where we are managing the online delivery of the symposium. And I'm very proud of the fact that this is being essentially led by a bunch of students, undergraduate students and PhD students at the center, who are working all the time to handle everything that is going on. We do not have any externally subcontracted management team. I would like to give them an introduction so that you know who's there in the background supporting this conference. So we have Arnab Bashak at IISER Kolkata, Bhuvarambiga Pari, Yoshita Barua, Shankita Chandra, Somaranjan Das, Shakshi Gupta, Anmol Kumar, Kushinjit Lairi, Shantanu Pal, Devashmita Nondi, Rajesh Nayak, Chitradip Shaha, Shobhik Roy, Shubhadeep Shina, Shoman Mondal from Asian Bose Center for Basic Sciences, and Ayan Banerjee at IISER Kolkata. So thank you very much, team, for being with us and for helping us host this symposium, and I really appreciate all the efforts you're putting in. Those of you who are in YouTube following us, we shall be live streaming the afternoon plenary sessions through 5 different channels: PS1, PS2, PS3, PS4, PS5. You are free to choose the channel that you would wish to enter based on your interest in a subject matter. You can continue to post your questions there. We'll have a moderator who will pick up the relevant questions and bring those to the Microsoft Teams delivery system where the primary speakers are being hosted. At this point in time, we shall be suspending our YouTube operations, the live stream in YouTube. It will come up again at 2 p.m. when we have the plenary sessions online this afternoon. Can I have confirmation?
It has been a challenging and interesting journey over the years with an array of satellites for communication, meteorological, remote sensing, navigation, scientific satellites, and when it comes to rockets like SLV, ASLV, PSLV